right, let's take a look. So we got a couple more applications to check out. How about something like this? If we are something like this, toy rocket is launched vertically upward from a 12-foot high platform with an initial velocity of 128 feet per second. So all that stuff is really sort of irrelevant because it's all absorbed into the function here. Its height h at time t seconds after launch is given by this equation, right? So h of t is the height function. So everybody gets what that does, right? What am I inputting into the function? The time. And what is the function giving back? The height of the rocket as a function of time. At any time, it'll tell me the height, right? Okay, we want to know how long will it take the rocket to reach the ground? So we have to interpret this, right? What's that? I mean, what's that code for? I mean, what am I gonna have to somehow be able to maybe set up an equation that I could solve to get some answers? What do you think? Ideas? What does this part mean? So we got to find time, but reaching the ground, what's significant about that? What is zero at the ground? The height. Yeah, right? The ground is a height of zero. Okay, so we just want to know when is h equal to zero, right? So all we're doing is plugging zero in for h, and that's going to give us the equation negative 16 t squared plus 128t plus 12 equals 0. Well, now we just switch into algebra mode and solve. Okay, so how are we? So now you can kind of just focus on the task. How are we going to solve that? Okay, we got a bunch of things. Go ahead. Quadratic formula. Okay, but is it so? In order to plug into the quadratic formula, though, does it meet the criteria? What's wrong with it right now? Yeah, a is negative. We never want a to be negative. We want it to be positive, right? Okay, so we got to multiply or divide by -1. Is there anything else we could do to make this an easier equation to solve? What do you think? Anson, you got an idea? Okay. Okay, yeah, we could factor out something, or we could even just, if we want to think about it this way, last time we did it, we factored something out and then divided. Let's take a shorter approach today and let's just divide both sides by something, by a constant, by a number. We can do that. So what's the biggest number that goes into all those things? 4 does, doesn't it? Right? How do we know 4 goes into 128? True. Oh, no, it's not. Yeah, but how do we know it goes into 128? There's a quick way you can tell. Okay. Yeah, I mean, so you could figure it out that way. If you had like a really big number, many digits, if 4 goes into the last 2 digits, it goes into the whole thing because 4 is going to go into every number of hundreds. So every digit after the second one is guaranteed to be some number of hundreds, right? It's got to go into those. Does it go into the first 2 though? Yeah, it does. 4 goes into 28, so it goes into the whole multi-digit number, right? So we could we could kill 2 birds with 1 stone here. We could take care of both things at once by dividing by -4. How about that? Okay, so if we do that, if we divide everything by -4, we're going to get the equation then. What? Positive. You guys tell me. Positive. I'll get you started. Positive 4t squared minus 32t minus 3 equals 0. Okay, good. Now, would we want to try to factor this? Probably not. We can tell right away because could we find magic numbers that multiply to -12 and add to -32? Good luck. right? That's not going to work, is it? Okay. So we're going to have to just use the quadratic formula. Okay, so we can do that. Quadratic formula. So then instead of x equals, we've got t equals. Raise your hand if you remember the quadratic formula. 100% sure you remember the quadratic formula. Not 100%. Okay, everybody quickly grab a slate so you have them here. Grab a slate and write out the quadratic formula.
These what slates are?
What's that?
These what slates are?
Those are the slates, yeah. Get a pen. Write out the quadratic formula.
He literally just said, right, sing it.
Yep. Yeah, you're good. Okay, one tiny mistake. What is it? Division bar. There you go. Good. 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 What's the equals? There you go. Just plus or minus. There you go. Yep. Good. Okay. Yeah. That's good. Yep. Okay. Good. Good. Okay, we're good. All right. So now let's plug in here. So what are we going to get? Throw me some numbers, Abby. 32.
Plus or minus.
Square root of. Okay, we might as well just square 32 though, right? And you got to be careful with that, by the way, because when we get into higher, start talking about polynomials, for example, you can't do that. If I'm doing, like, if it's going to be negative 32 cubed, then I have to cube it out, right? Because I'm going to get a negative answer. Does that make sense? It's only for even powers of a number, of a negative number. So 32 squared minus, keep going, times. Okay, what's going to happen to my signs inside the square root if I subtract? Yeah, good. I'm subtracting what's going to be a negative product, right? So I do that. Okay. All divided by 2 times, you said 8. Yeah, 2 times 4. Okay, good. So if we simplify, we get 32 plus or minus the square root of, oh boy, what's that going to be? 30 squared is 900. So we're going to get, you're going to add to 900, you're going to add 30 plus 2 times 31 plus 32. So you're going to add 92 plus 32 is 124. So you're going to get 924. Is that right? 1,000? 1,000. Oh, you're right. Yeah, I didn't add the 100, did I? Yep, you're right. 1,024. Whoops. You saw my mistake. That's good. 1,024 plus, what, 48? All divided by 8. And so we get T equals 32 plus or minus the square root of 1,072. All over 8. Okay, 1,072. Let's see. 1,072. We'd have to make a factor tree, I suppose, for that. Okay. What's a number that divides into 1,072?
536.
Okay, can we pick a bigger one so we don't get such a long factor tree? Say it again. 9's not going to, because 1 plus 7 plus 2 is 10, which is not divisible by 9. Look at the 4s and the 8s. Does 4?
8 does. 8 would.
Okay, how come? You know 4 does, because if 4 goes into 72. You know 8 does, because 8 divides evenly into the first 3 digits. Well, 8 goes into 10 once, right? With 2 left over. 8 goes into 27 3 times with 3 left over. 8, so 134 and 8. Okay. And then 134 is going to break up into 2 and 67, which is prime. Okay, look at these two. That's 2 times 8 is 16, right? So that's going to give us a 4. Everybody see that? These two combined, we could do this. Like these two, we'll just replace with a couple of 4s, right? And then we've got a single 67. Everybody get that? Okay. So we're going to get equals 32 plus or minus 4 times square root 67, all divided by 8, which we could simplify, couldn't we? So that's going to give us 4 plus or minus 4 to 1/2, so square root of 67 over 2. Okay. All right. I got 2 answers, though. What are we going to do with that? Let's turn those into decimals. How about? We'll just go out to like 3 places. Somebody, real quick, tell me what those are. What is 4 plus the square root of 67 over 2? Yeah, let's do it on a calculator. It's going to give you, square root of 67 is going to be like 8.2-ish, 2 something. What'd you get? 8.25-ish?
Why is that not?
That's not right.
8.18.
0.18, okay. So 8.18 over 2 is 4.09, right? 4 plus 4.09 is about 8.09. Or 4 minus 4.09 is going to be about negative 0.09. Okay? So now a lot of times when we solve, we're using a mathematical model to solve a physical situation, right? So we flipped into math mode and we solved it, but now we have to interpret our results through the lens of the original problem, application. So which of those is going to make sense?
Not the negative.
Probably not the negative one, right? Okay, what is negative time? No, it's the past. That's all it is the past, right? So if we're going to start the stopwatch right when the rocket is launched, negative time would mean that was a little bit before we started the stopwatch, right? That probably doesn't make sense in the context of this problem, right? So we probably want the positive time, which is 8.09, and they didn't give us specific instructions, but typically on these it's going to say round it to a certain number of decimal places. Okay, so our answer then is going to be about 8.09 seconds. Okay, give me 1 to 5. Does that make sense? Okay. Now there's something else though that we can take away from this. The math gods are never frivolous. They gave us some information there that might be useful. We just don't know how to, we didn't initially see how to use it. But that negative 0.09 might actually be interesting if we think about it. Now let's draw a physical picture of this for a second. So here's the ramp, right? This thing is launched, it's 12 feet high is where this thing is launched, right? So the rocket goes up and it comes down, okay? And we figured out how long it took to hit the ground, right? Okay, if we were, what do you think? It's, well, okay, kind of. If we were to graph this thing on Desmos, which I'm going to do really quick, you're right. It is that. It is that for reasons that are slightly different, I think, than what you're suggesting. But that's pretty good. That is what it. That's what that means. It's how it can be interpreted. So what's our? Okay, so there's our original function. Let's graph this guy. Oops. All right, thanks. Solomon's not here. I'll give that one to you. There you go. Thank you. Shane, you got something there. Okay. So now look at this. There's our graph, right? That doesn't look great. We're going to have to manipulate the graph settings a little bit, right? You everybody see why? Because the y it's really stretched out vertically. So we can just go into the graph settings and let's pick something like, let's let x go from, oh, what do you think? -1 up to +9 by ones. How about? Oops, by ones. Okay. And then on the y-axis, I don't know. We're just going to have to estimate. Let's go from -5 up to 200. No, whoops, what'd I do? Oh, geez. -5 up to 200. Not quite. So what do you think? 240? No. 300? 320? There we go. Good enough. Okay, so there's our function. And look, there are our 2 zeros. Okay. Now think what this is here. This is not a physical graph. This is a graph of height as a function of time, right? Don't make the mistake of thinking this is what the trajectory of the rocket looks like. It just went straight up and straight down, right? But this is height as a function of time. Okay, well, the math gods told us when it would have impacted the ground initially, or when it would have been at ground level, if we had done a slightly different experiment. Instead of the rocket starting off from a platform 12 feet high with an initial velocity of 128 feet per second or meters per second, whatever our units were, what if instead it had left the ground and gone whizzing by the edge of the platform with that velocity when it went whizzing by the platform? How long would it have taken to go from the ground up to the level of the platform where we started the stopwatch? Well, it would have taken, 0.093 seconds. So it actually did tell, the math gods told us something interesting. It just wasn't what we were asking for, right? Okay. Let's put a picture of that in there maybe, huh? All right. Another one down. How about this one? One leg of a right triangle is exactly twice as long as the other leg. The hypotenuse is 4 centimeters longer than the longest leg. What are the lengths of all 3 sides? So I gave us a little picture of a right triangle. That's generally kind of useful. So what can I do? They don't tell us any specifics, but they tell us one leg of a right triangle is exactly twice as long as the other. How could I represent that? X and what? Not x squared, twice as long. 2x. There you go. Good. So we could do something like this, couldn't we? We could say this is the short leg x. Oh my goodness. This one is the longer leg, that's 2x, and the hypotenuse is 4 longer than the longest leg. So 2x plus 4. Okay, so there's our relationship. I just need to have some kind of I need to be able to set up an equation involving x. What do we know about right triangles geometrically that would be useful to us in setting up an equation? Okay, good. The sum of the squares of the legs equals the square of the hypotenuse, right? Pythagorean theorem, okay? So what's that telling us then? X squared plus 2x squared, the quantity 2x squared equals, okay, the quantity 2x plus 4 squared, right? Okay, how am I going to go about solving this? What would I have to do? What do you think? Ideas? What do you think? Yes, sir. Expand them out. Yeah, good. Okay, so let's expand out all those expressions. So what is the quantity 2x squared? Yeah, I got to square the 2 and square the x, right? And if I FOIL this one out, what am I going to get? Well, I'm going to get 2x. I'm going to distribute the, well, I guess we could write it out, right? We could write it like this if we want to. 2x plus 4 times 2x plus 4. So I'm going to have to distribute the 2x there and there. What's that going to give me? 4x squared plus 8x. And then if I distribute the 4 there and there, okay, plus another 8x plus 16, okay? So where am I going to push everything then? We want a positive number of x squareds. Okay, right. So I could do, one thing I could do here is I could subtract 4x squared from both sides. Everybody see that? Okay, and now I want to push everything over to the left, don't I? Okay, makes sense. I have a positive. Okay, good. So then these terms, combine those and push those left and push that left. And if I do all that stuff, I'm going to get, Madeline, what am I going to get then? X squared minus 16x minus 16, good, equals 0. Okay? So could we factor that? No, we can't. There are no numbers that multiply to negative and add to negative 16. So what are our options here? Quadratic formula would be fine. Would this be a good candidate for completing the square? It would be, right? Because A is 1 and B is even. Everybody see that? So this actually would be a pretty easy one to do, completing the square. Let's do it that way, being as we haven't done that in a while. Yeah, negative 16 is even, right? So we're going to get x squared minus 16x space equals 16, right? So then what's this going to factor into? Already we know x. Well, what is it that we're, which is what? Negative 8, right? Half of b is negative 8. When we square that, what are we actually adding? 64. Okay, but what's that going to factor into? X minus 8. And over here, we just get 80, right? Look how easy that is, right? Completing the square makes this pretty simple. I think, to me, that's quicker than quadratic formula. I mean, it's probably a wash. So then we get x minus 8 equals plus or minus the square root of 80. That's 16 times 5, right? So 4 radical 5. I'm just going to add the 8 there. And it's 8 plus or minus 4 radical 5. Okay? All right. Okay, so of those two, how come we got 2? Are those both going to work geometrically? Yeah. 4 radical 5 is bigger than 8, isn't it? Okay, we know that. We know it's bigger than 8 because 4 times the square root of 4 is equal to 8, right? Square root of 4 is 2. Square root of 5 must be a little bit bigger than the square root of 4, so we're subtracting a number slightly bigger than 8. Okay, so because you could never, for a geometric shape, you can never have a length that's equal to a negative number. That makes no sense, right? You can only have length. Lengths must be positive. So we could discard this, the negative one, because no length can be negative. And we get the answer, x equals 8 plus 4 times the square root of 5. Now, that's our mathematical answer. What would we be wanting to do with that up here? Well, we could fill that in. Everybody see what we could do with that? We could fill in all of the values for x. So this one would be that one would be just plain old x, right? What we just solved for. This one is 2 times that. This one is 2 times that plus 4, right? Everybody get that? I won't really take time to plug those in, but we still would have to, I'll make an arrow up here to remind us. We still have to feed that value into all those to get the precise side lengths. Okay, give me 1 to 5. How are we doing? How are we doing on that? Okay. All right. Okay, how about something like this? This is really similar. Maybe we'll just set this one up and you guys can, we can just talk about how we could do it. You decide how far you want to go with this one. The height of a rectangular prism is 3 feet. So I could make that 3. Everybody agree? That's the height. The length and width can be expressed as x minus 1 and x plus 4. So what's that mean? So like that dimension and that dimension? Okay. So we could make that x minus 1 and that x plus 4. If the volume is 198, our units are cubic feet, how could we find the value of x? How could we set up an equation then? Yeah. How you find the volume of a rectangular prism by taking the product of all 3 side lengths, right? Everybody see that? So 3 times x 1 times x plus 4 equals 198. And so we could just expand that out and create a quadratic equation to solve then. Everybody see that? Okay. Do we want to keep going with that one? We good with that, just seeing how to set it up? Okay. Okay, so then let's see that one. What's the other one? Let's do, okay, let's at least set this up. Ken has a rectangular shaped vegetable garden that's 15 by 9. He would like to increase the length and width by the same amount, x, so the new garden is twice the current area. Okay. Right, so we could do, I usually make the length the longer one, the width the shorter one, right? So let's just create a little picture. Okay, so here's what we're starting with, right? And we want to make a bigger garden. that looks like that maybe, right? Everybody agree?
Yeah.
Okay. So what are the dimensions of our starting garden? Okay. Which gives us a, what is that, 135? Our total area is, we'll make those, are they feet? Yeah. So it's 135 square feet is the area of that one, right? Okay, what are the dimensions of our new garden? Oh, what are they going to be? Hang on, let's see here. Sarah Lynn, what are the dimensions of the expanded garden going to be? If we're increasing each dimension by x. 9 plus x and 15, oops, my goodness. 15 plus x. Okay, so then the area of that is what I get when I multiply those out. Everybody agree? Okay, so the red area is just going to be, I'm going to flip those around. I'm going to commute the two terms in those sums. So x plus 9 times x plus 15. If I FOIL that out, what am I going to get, Oscar, if I FOIL that out? What if I distribute that x? What do I get?
X squared plus 24x.
Okay, good. I'm going to get 24 total, aren't I? When I distribute everything, I'm going to get 15x plus 9x is going to give me 24x. And then plus 135. So there's my area of this garden. Ah, good. Okay. And the prescription was we wanted to expand so the new garden is twice the original area. Okay, look at that. So then we end up with the equation 2 times the original area, 135, equals the red area. Okay, now what am I going to do from there? Yeah, right. I'm just going to have to put this into standard form and solve. Okay, so 270, this just is 270, right? What am I going to do? Okay, good, because I already have a positive number of x squareds. So I just come up with the equation then, x squared plus 24x minus 135 equals 0, right? If I subtract the 270 from both sides. Okay. Can we find numbers that multiply to negative 135 and add to 24? We might. So 30 and negative 6 would be too big. So how about 29? 20, I bet it's going to be 29 and negative 5. No, sorry, 20. Is that it? That's it. 29 and negative 5, right?
27. Because 29 is 145. So 29 times 5.
Negative.
It says it's 145.
20.
That's 140.
Oh, it is 145? Okay.
It says 27.
No, because that doesn't have.
Oh, yeah. Oops.
We're not going to, are we? 27. It's not going to work. 27 and negative. No, it's not going to work, is it? No. Okay, so we're going to have to use quadratic formula. Never mind. But we could just plug that in quadratic formula and get solutions. And then when we get the solutions, here, let's do it really quick. I just want to see what happens with this. So x is going to equal, throw some numbers at me.
X equals -24 plus or minus the square root of 24 minus 4
Yeah, you bet. 4 times 1 times. Okay. Now, look, you can already tell what's going to happen here. Can I keep the negative in the plus or minus? No, because that's going to give me a negative total, isn't it? Over 2. Oops. What did I just do? I don't even know what I just did. Go away. Oh. There we go. Everybody see that? And we're trying to find the original. We're trying to find the amount that we're increasing the garden size by. So it can't be a negative amount, right? So we know already. We know that I could get rid of that, couldn't I? And just take the positive one. And I'm just going to get whatever I get when I simplify that. Okay, good. All right, last one, and we are good. And we'll just set it up. If the area of the shaded region is 59 square inches, what are the dimensions of the outside rectangle? That's a good one. The area of the shaded region is 59. How could I come up with the area of the shaded region geometrically? Any ideas there? What do you think, Sarah Lynn? Yeah, I could do area by subtraction, right? The big rectangle minus the little white rectangle gives me the area of the shaded region. Agreed? Okay. So we could do then the big area, wouldn't that just be 2x minus 1 times x plus 6 minus the small area, x plus 3 times x, has to equal 59, right? So what good does that allow it? What good does that do for us? Okay, so I have an equation that I could use to solve for what? X, exactly. I could use the equation to solve for x, and once I knew what x was, if I knew the value of x, I could just plug that value in to those dimensions to find out what everybody agree? Okay, so that's, if I FOIL this out, what am I going to get? Let's just go through these steps. See if you can do this. If I distribute the 2x and I distribute the -1, I'm going to get, what, 2x squared plus 12x minus x. What's that? 11x minus 6. Okay, minus whatever I get when I FOIL that out, which is just x squared plus 3x. Everybody agree? I don't really have to FOIL it out. I just distribute the x. And all that is equal to 59. Okay, so then if I distribute the negative, isn't that giving me minus x squared minus 3x? So I could combine like terms and get 2x squared plus 11x minus 3x is plus 8x. Oh, whoops, I didn't add the x squareds, did I? 2x squared minus x squared is what? Yeah, 2x squared minus x squared is going to give me just an x squared, right? So x squared plus 8x minus 6, whoops, minus 6 equals 59. I'll subtract the 59 and I'll get x squared plus 8x minus 65 equals 0. That does factor, doesn't it? Oh, no, it doesn't. Yeah, it does. What's that factor into? Well, negative 5 and
A big number.
13. Yeah. Right? Okay. So this one does factor, and it's quicker to do that. X plus 13 times x minus 5 equals 0. So look what we get then. X equals negative 13 or x equals 5. Which one would we have to keep? Well, could we? Negative 13 is not going to work, is it? How come?
It'll leave negative.
Because I'm going to get negative dimensions, right? Would negative, no negative is going to work here, is it? But it's conceivable that maybe a negative would have worked if those had been slightly different expressions, and when I plugged it in, I still got positive answers, right? But in this case, negative 13 is no good. Oops. Oh, what I put the, is that us? Yeah. Negative 13 is no good. So 5 is our answer, which I would then have to plug in up here. Right? So what would the dimensions be? That's going to give us 5 plus 6 is 11. 2 times 5 minus 1 is 9. 11 by 9. Does that make sense? Okay. All right. Man, we got through a lot. Okay. 1 minute to spare. How about that?
I said you better be packing up because I'm leaving with the boat.
Oh, no, Sarah, I'm not going with you.